In this demonstration, I will show a couple of things. First, how to apply a pre-trained deep learning model created in Aivia Cloud, and then how to check the quality of the image restoration that we've achieved. And we will do that using one of the new features of Aivia 8.8, which is the Python integration, which allows us to run a script written by Patrice Mascalchi from the team based in Europe. So in this dataset was created with SP8 with the resonance scanner, and it shows some labeled neurons. Dataset was created by Hu Zhao at Texas A&M, and dataset, the input data is relatively noisy, as you can see, because it's a single scan. The ground truth data is substantially better, and that is composed of images created with 49 average scans, so 49 or 48 scans that were then averaged, and that's what you get here. So much higher quality image as the ground truth. And that image was also deconvolved, the ground truth image, whereas the raw data was not deconvolved, and it's a single scan. So we've trained the model, as I mentioned, and now I'm going to apply that model. Here is the model, so I can drop it into Aivia. It will create a recipe. I choose the raw input. I can set a region of interest if I want to run this quickly, or I can just run it on the whole image, and that's what I will be doing. So input the raw image. I'll run it on the whole data set. Let me show you what that looks like. So when you start it, it will take a little bit of your GPU dedicated memory. I'm using the RTX 2080 in my laptop, and then the CUDA will speed up and get to nearly 100% over here while the image is being processed. When it does complete, you will see a note on the bottom of your screen here indicating that Aivia has finished processing that image. So the result is this channel over here, and that's what the result looks like. So that's the raw input. That's what we're getting by applying our pre-trained model, and this is the ground truth. So certainly a huge improvement versus the raw data to get to this, but perhaps not as good as the ground truth. And that's really what I wanted to check now. So we have, as I mentioned, the possibility to now write your own Python script. This is one written by Patrice in our team based in Europe. And you can see his script here. And so this script is ready to go. All I have to do is drop it into Aivia. That's the same one we were just looking at. So I'll drop it in here. It will create a recipe, and I can take ground truth is the ground truth. Restored is my result, and I'm going to run that. Okay, that's complete. You can now have a look at the result here. So let me turn this off. So it helps to have a color map that is a little bit more indicative. So rainbow 1 is good. So if it's a very low intensity value, it means low confidence or high disagreement. So this is low quality. Everywhere you see these kind of colors, and red more specifically indicates that there is disagreement between ground truth and the reconstruction. But generally it's in the blues and greens, which means there's a big agreement between the two images, between the ground truth and the restoration. So this would illustrate an area down here in this area. So this area here is probably where there is most disagreement, and we can check that. So I can now turn on, that's my result, and this is the ground truth. So in this area this Python script identifies that there is significant disagreement. Whereas in other areas, let's see up here, there is less of that disagreement. So this is the ground truth. Oh, sorry, this is the result, and this is the ground truth. So this is a higher quality restoration versus what you saw at the bottom. Okay, now that we run it for a comparison between the ground truth and the result, and I'll just rename this so that we know what we've done with this one. Now I'll run the same analysis, but instead of the result, I'm going to compare it to the raw data and run. Okay, it has completed. So let's have a look. This is the new one, SSIM image. I'll do the same exercise, just change here the lookup table to the same one I used before, and change the name. Okay, and you can straight away see that most of the pixels on this image indicate high disagreement between ground truth and raw data. So just for comparison, this is ground truth versus result, this result or restoration, and this is ground truth versus the raw data. So versus the restoration versus the raw data. And it's no surprise considering the raw data looks like this and the ground truth looks like this. Okay, so that's the exercise that I wanted to run. So a couple of things: apply a pre-trained model and then check quality using a Python script that integrates now into the Aivia platform.